The world is big enough for everything. For thousands of years, humans and water have coexisted. We admire its richness, we accept its help, and we fear its impermanence. That's why we try to control it. Now, we look at nature in awe and adjust the way we deal with water. With rich imagination and innovative technology, we gain energy and power from flowing water. We keep exploring so that our civilization can last. Fast and efficient production lines, with powerful machines working non-stop, pursuing ultimate production capacity in countless Chinese factories. Unforgettable scenes like this are common life. It's a vivid and intuitive representation of made in China and the surging potential energy of innovation that's inspiring the equipment industry in China. A piece of steel weighing 43 kilograms is loaded into the fitter's bench. This is the moment that it stops being just a piece of metal. It will work as a magnetic pressure plate and become a part of a hydro generator. 1,000 miles away, a renowned hydropower station is its destination. Gezhouba Hydropower Station is the first large hydropower station on the Yangtze River. Chinese people proudly named it the greatest dam on the Yangtze River. For 40 years, Gezhouba Hydropower Station has provided 600 billion kilowatt-hours of clean electricity in total. The power is enough to replace 184 million tons of standard coal, infusing the development of China with strong vitality. The glory of the station comes from two 170,000 kilowatt generator units completely designed, manufactured, and installed by China. In the 1980s, these generator units, together with the atomic bomb explosion and satellite ascension, were the glory of the Republic. As the theoretical service life approaches, renovation of these two meritorious units is imminent. However, revitalizing the units back to their former glorious state is a big challenge for designers.
In the 1970s and the 1980s, China didn't have enough capacity for either economy or manufacturing. But being able to produce the model and exhibit China's capability in hydropower equipment manufacturing was a great honor for us. And now that this task is on us, it's no longer about if we can produce the model, but it's about if we can do better.
90 days, that's the due date of this renovation project. The team is determined to fight for the glory. Rotor, the rotating part of a generator, generates a magnetic field. Gezhouba Hydropower Station's 70,000 kilowatts turbine rotor is 16.9 meters wide and 2.4 meters high. Its gross weight is about 900 tons. Its diameter is the longest among the axial flow Kaplan turbine rotors in the world. The magnetic pole pressure plate is ready. The assembly of the magnetic pole core begins. As the core component of the rotor, the magnetic pole core provides electromagnetic induction for the hydro generator. The engineers need to install 110 pieces of magnetic pole cores on the rotor. A single magnetic pole core is 2 meters long and weighs 1.5 tons, comprising 1280 pieces of high-strength steel plates. When the magnetic pole core assembly is finished, the length tolerance must be no greater than 1 millimeter. As the last piece of steel is accurately put in place, the assembly of the magnetic pole core is finished. The complex and delicate process that is coming up will be taken over by robots. Laser tracking, acquiring data, automatic positioning. The intelligent arc welding robot is exhibiting extraordinary skills in every way. It fills the thousands of semicircular groove gaps formed from magnetic pole core assembly one by one, thus significantly enhancing the integrity and rigidity of the magnetic pole core. This change from humans to robots represents the iteration of welding methods. Though it's just a small step in the grand industrial process evolution, it means much more for Chinese hydropower equipment manufacturers. The iconic moment is finally happening. After renovation, one of the 170,000 kilowatt units in the Gezhouba hydropower station is starting its first rotor smoothly. After more than an hour of intense work, that mega piece is successfully put in the machine pit. The assembly is completed. The grand unit renovation project is still progressing under pressure. Precision casting for the steel blades is done. The 8-meter high turbine structure is already waiting. Today, they will be combined to form the super heart of the hydro generator unit, the runner. The assembly task is assigned to an experienced and meritorious technical team. Over the past 30 years, they've been one of the best in multiple world-class hydropower equipment manufacturing projects. This time, they are going to renew their record by exhibiting more sophisticated assembly techniques. The crane starts to pull, and a blade steadily approaches the shaft socket of the runner. To join the 30-ton blade with the shaft socket perfectly, the horizontal error cannot exceed 0.1 millimeters. The accuracy is comparable to the docking of Shenzhou and Tiangong. The larger the diameter and the weight of the runner, the harder to produce it. The Gezhouba 170,000 kilowatts unit turbine runner is 11.3 meters wide. It remains the world record holder of the longest axial flow runner diameter. The modified runner adopts new materials and construction, improving the performance of the unit greatly in terms of overflow capacity, hydraulic efficiency, and cavitation resistance.
Lower. More. Lower.
The force applied is accurate. The blade accurately matches the shaft socket. The adjustment is done. The first blade assembly is a success. A day later, as the last blade is precisely installed, the runner that weighs 513 tons in a hole is successfully assembled. This wins the final battle of Gezhouba 170,000 kilowatt unit renovation project more time. 170,000 kilowatts is the starting point of China's hydropower equipment on the rolling Yangtze River. From this starting point, China's hydropower equipment has been advancing for 40 years to chase after the dream. Green electricity rolls on day and night. The Gezhouba River starts from the Gezhouba mountain and runs all the way down through mountains and waters. At the border of Sichuan and Yunnan, the rolling river water turns into a blue lake. Among the mountains and deep valleys, the world's largest hydropower station is under construction, Gezhouba River Baihetan Hydropower Station. Its double curvature arch high dam is the third highest and the most anti-seismic in the world. The non-pressure spillway tunnel group is the world's largest. It can fill the West Lake in 18 minutes. The underground cavern group is the longest in the world, equal to 1.7 times the distance from Beijing to Tianjin. As one of the fastest-growing countries in the world, China's demand for clean energy has always been strong. As of 2021, the total installed hydropower capacity in China has reached 390 million kilowatts, which is one-third of the world's total installed hydropower capacity. The total installed capacity of Baihetan Hydropower Station is 16 million kilowatts, second only to the Three Gorges Hydropower Station. There are 16 hydro generator units on the two banks, each with a capacity of 1 million kilowatts. The technology is a first in the world. A single unit generates 1 million kilowatt-hours of electricity per hour, which is the 250 years of electricity consumption of a modern family. Developing generator units like that is as hard as climbing the highest peak in the world in the hydropower industry. Without any reference, Chinese hydropower equipment enterprise conducted scientific research that took 10 years and formed a knowledge system comprising general design, hydraulic development, electromagnetic design, high-voltage insulation technology, etc., all with independent intellectual property rights or prominent importance.
Highest level of efficiency, optimal cooling effect. Those are the R&D goals we set at the time. To complete the development of the Baihetan project and achieve our technical goals, the traditional technical route and plan won't be sufficient. We must innovate in key technologies.
300 meters below the power station hides the giant hydropower unit. In the underground factory building on the left bank lies Unit 6 that is over 50 meters tall and weighs more than 8,000 tons. It's going through the pre-commissioning idle test. The object is to limit the maximum overall swing amplitude to the diameter of one strand of hair. The unit rotates at high speed, reaching up to 111.11 revolutions per minute. Each revolution is an ultimate test of the unit's technical performance. For the unit, any tiny error in the vibration and swing of each rotating part, or the whole system, comprising oil, gas, and water could become a fatal threat. The 5-hour uninterrupted idling test requires the full strength of the unit and the team.
We have an internal critical standard. For example, if the client asks for 0.2 millimeters, our internal standard is usually more critical. We may control it within 0.1 millimeters.
Unit 6 is still roaring, while Unit 8 is in the last stage of installation. This is the last unit of Baihetan Hydropower Station on the left bank. The 21-meter diameter upper rack is in place. The collector ring, the core component of the unit, is moving in the air. With the help of an overhead crane, this 3.5-ton oversized ring is finally uniting with the float valve that has been waiting for long. The inspection of the turning machine for alignment is a test for both humans and the equipment. The generator unit consists of a plurality of rotating parts, all longitudinally fixed by the upper and lower frames. The cumulative error of all rotating parts during installation may cause some kind of bending in the axis of the unit. The inspection of the turning machine for alignment is to measure and adjust to ensure the axis always stays in a straight line. Tan Jianwei, an engineer, is fast and accurate. He must make sure that each link is foolproof. In the last 4 years, Tan Jianwei has personally experienced the whole assembly process of 7 units. This time, his wish remains that the result can be perfect. The turning machine for alignment inspection begins. The collector ring and the float valve rotate at the speed of 1 or 2 rotations per minute. The dial gauge is recording their swing accurately. After more than 20 hours, all test results show that the swing of the collector ring and the float valve is 0.1 millimeters. That's better than the critical standard. However, for Tan Jianwei, to ensure that all units can operate safely, smoothly, and efficiently as the target, his work is not done yet.
Although this is the last unit, we still need to control the quality of all sections like before. When Unit 8 starts to work, it should also meet the critical standards like the ones before.
Since commissioned, the station has generated a total of 25.6 billion kilowatt-hours of green electricity. After construction, the expected average power generation under full capacity is up to 62.4 billion kilowatts, which can replace approximately 19.68 million tons of standard coal, reducing carbon dioxide emissions by 52 million tons. With the Baihetan Hydropower Station, China's total installed hydropower capacity on the Yangtze River will reach 71.69 million kilowatts, which equals to 3 Three Gorges dams. This is the route of rising of the biggest clean energy corridor in the world, and the route of innovation for major hydropower equipment from made in China to created in China. Amid the global shift towards green and low-carbon transformation, China is showcasing impressive innovation in harnessing hydropower. Advanced energy storage technologies, with more prominent advantages, are driving China's efforts to bolster energy security and promote sustainable development. At the upper reaches of the Luanhe River, deep in the Yin Mountains, two giant reservoirs span the valley. Hebei Fengning Pumped Storage Power Station, the world's largest pumped storage power station, is located here. Twelve units of 300,000 kilowatts hydro turbine generators were designed, manufactured, and installed all by China. Their total installed capacity is 3.6 million kilowatts, the largest in the world. Maximum energy storage at one time is nearly 40 million kilowatt hours. That is a top in the world. Pumped storage hydropower uses water as the energy storage medium, converting electrical energy into potential energy and then releasing it to generate and store electricity. A pumped storage power station consists of two reservoirs with different altitudes, water turbines, pumps, and a water delivery system.
When the electricity is abundant, the surplus shall be stored, then release electricity when the demand for electricity is high. Utilize the altitude difference between the upper and lower reservoirs to pump the water to the upper reservoir and store energy. It plays a regulatory role in the whole grid.
Pumped storage hydropower is the earliest, large-capacity energy storage technology with a history of 140 years. It has been in practice since the mid-20th century and has been the most widely used energy storage technology in the world. After trying to catch up for half a century, China moved up in the competition and became a dominant player in the pumped hydro energy storage industry. As of 2021, the installed capacity of pumped storage power stations in China reached 36.39 million kilowatts. The scale of operation ranks first in the world. What gives Fengning Pumped Storage Power Station the ability to hold its place among the top 10 pumped storage power stations in the world is the 12 powerful generator units. This powerful system can ensure that the power station provides a regulating output equivalent to 1/3 of the Three Gorges Dam's capacity under special circumstances. In the underground powerhouse, Unit 10, selected as part of the first batch of generator units, is currently being assembled. Supplying 100% green electricity to the Beijing Winter Olympics on schedule is a target for the power station and a shared aspiration for everyone involved. The stator lamination is 0.5 millimeters thick. It's the heart of the generator and the most important component of the stator core. In Fengning Pumped Storage Power Station, each generator set requires 140,000 pieces of stator lamination. They all come from an unmanned workshop 2,000 kilometers away. In the fully digital drive workshop, the silicon steel used to produce stator lamination goes to the stamping machine by automatic feed press. Then stator lamination pieces made are carefully stacked by robots. From raw material delivery, through stamping, and then to final assembly, the entire production process of stator lamination is managed by an intelligent control system, eliminating the need for direct human involvement. Even so, Zhong Jian, an engineer in Fengning, Hebei Province, is still concerned. The 140,000 pieces of stator lamination need to be stacked one by one with human supervision and form the 3.08-meter high annular stator core. The stacking error cannot exceed 0.4 millimeters. This is no easy feat.
Each punching produces deviations. After they are stacked, we need to reshape them, align the top and the groove shape neatly. That's the hard part. Quality control during installation is up to the highest standards of the industry. That is the best. You can't top that.
Three months before the opening of the Beijing Olympic Winter Games, the final assembly of Unit 10 is completed. However, Whether it can start up successfully on the first attempt and ensure a reliable power supply for the Winter Olympics depends critically on the joint commissioning of all systems of the unit. A key feature of the Beijing Winter Olympics is that all venues will be powered entirely by green electricity, a milestone unprecedented in the history of the Olympic Games. The Black Start is Fengning pumped storage power station's unique skill. When an abnormality occurs in the power grid, the unit can respond within 3 to 5 minutes, swiftly switching from a shutdown state to full load operation, thereby providing electricity to the affected area. The alarm of Unit 10 is sounding. The differential pressure of the main inlet valve's hydraulic oil filter is abnormal with the cause unknown. This confused Zhou Wei, an engineer. 21 meters below the underground powerhouse lies a maze of various pipelines. Right in front is the main inlet valve. With a diameter of 2.3 meters and weighing 120 tons, the main inlet valve acts like a faucet. It is hydraulically driven to open and close itself. In emergencies, it is responsible for shutting off strong water flows to ensure the safety of the unit and the power station. After ruling out possibilities such as sensor failure and filter clogging, Zhou Wei suspects that the differential pressure alarm of the hydraulic oil filter for Unit 10 main inlet valve might be due to changes in hydraulic oil viscosity caused by temperature variations. Further investigation confirms his suspicion.
Hydraulic oil, when used in the north, has a higher viscosity coefficient. This has never happened when we were working in the southern areas. After identifying the problem, the next is to solve it. When solving the problem, even if I have to learn, the process is quite satisfying. No matter how small the problem is.
December 30th, 2021. The first batch of generator units of Hebei Fengning pumped storage power station are officially in operation. As the water rises and falls, 600,000 kilowatts of green electricity is continuously transmitted through the plus or minus 500 kV Zhongbei flexible DC grid to the venues of the Beijing Winter Olympics. In 2024, Fengning pumped storage power station will be fully completed and put into operation. The expected annual power generation is 6.6 billion kilowatt-hours, providing the Beijing-Tianjin-Hebei region strong support in green-oriented transition of energy. Now, with Fengning pumped storage power station as a new starting point, China's pumped storage development is accelerating and intensifying. This progress aims to achieve the goals of carbon peaking and carbon neutrality sooner, drive high-quality development with robust green power, and offer a valuable Chinese solution to the global challenge of large-scale development and utilization of renewable energy.